Okay, so right, it was a little simple mistake that I made, but important to note. So let's just try this again. So just to recap, I was going to show you how to use the lip and the groove, and I had neglected to choose two bodies. So on the left-hand side, you'll see body part selection. I had selected the first one, which shows you where to put the groove, I think. Groove, and the second one, the lip. If you don't select both bodies, then it'll just give you one. So I'd forgotten to click in there that I wanted the lower body to hold the lip. Then you can select a plane for directionality, and that's just, in this case, the top plane. It just has to be perpendicular to that plane. Hi, Thirstein. Okay, so then we'll move. Hi. You'll move to, as soon as you click on the groove selection box, it'll hide the other body that you don't need, and you can select on this face. It's not showing nicely because the colors I've chosen sort of conflict with Solidworks' one, but you can see it's chosen that face. And then you don't need tangent propagation, but inside this next one, which is the edges, if you right click on one of the inside edges and you say select tangency, it'll select all the edges you need in one shot. You can of course do it one by one if you want, and if you want selected edges, you can do that too, though I'm not sure it'll always work. All right, so then you can move on. Once you've got that established and you've clicked on this tangent propagation button, move to the lip selection. So we've got groove selection and then lip selection. And it immediately highlights the other body, and this top one will be ghosted. And so I can select this top face, which now highlights nicely. And then I can move across to the edge selection, and I can right click and select tangency. And I'm selecting, you must select the corresponding edge. Don't select the inside and the outside. You're going to face problems. And then I'm going to select tangent propagation, although it's not going to like it. But we'll see why shortly. All right, so then this, I don't know if you'll remember, but you'll see if you go through the video again. The last one, because I'd only chosen the uppercasing boss, I'd only chosen the groove part of it. It only showed the groove part of this drawing, but it'll show the whole drawing. And so you can see by the keys here, A is 0.52. That's from where is that? That's from that edge, I think, to, no, sorry, that's the groove. That's the sort of gap between the groove. And then you'll see it shows a gap here because you actually want a gap. So B is the gap, and I want a gap here of 0.05 millimeters. That's because when I want to put this thing together, the one can't squeeze onto the other. It has to have a little bit of a gap so it can slide in nicely and move from side to side and back to front. That's tolerances. We'll get onto that later. Then that's the degree. C degrees is 5 degrees, sorry. C, that's just the angle at which I want to make that lip and groove meet one another. And D is 0. So do I want the groove to meet the top of the lip face to face, or do I want them to be offset slightly? In this case, I want them to meet face to face. And then E, 0.9 is the height. So I've made the height of this the same as the width of this, what do you call this? The edge, the wall. And then F, it'll default here. Like if you've chosen, if your wall thickness is 0.9 and you've chosen 0.52 here, it'll automatically deduct 0.52 from 0.9. And anyway, it'll calculate this for you, 0.7. That's, I think this 0.447 is 1 millimeter. So it's actually calculated this for you. And then H is 0.25. So that's that little gap between the two faces, which you often want. It's what you call a witness line or a shadow line. A shadow line, in fact, I think is the right term. It's just a nice little feature, especially on cheaper moldings. If they don't meet nicely, you want a shadow line to hide the imperfections. Once you're happy with all of this, you say OK, and now it's going to give me an error message. It's going to say unable to maintain the existing sidewall faces, additional non-drafted faces. I'll show you what that means in a second. It just means that one of the faces, we couldn't keep tangency, this tangent propagation. So I'll say OK, and then just let's have a look at what we've got. So I'm going to go to the section view, go to the front face, and if I zoom in here, there's that 0.5 mil gap. Here's my 0.25 shadow line or shadow gap. Those two are meeting exactly. And if you look carefully, you can see that this face and this face are not tangent to one another. That one's sitting at 1 degree and this one's sitting at 90. So if I want this part to demold properly, I'm going to have to reintroduce this this draft. Okay, so let's go out of that. For the sake of completeness, let's reintroduce that draft that's missing. So I'm going to click the draft command. This face here will do the trick. And then if I just right click and say select tangency, those are the faces that are going to be drafted at 1 degree. Say OK. Select the view. There we go. Zoom in, and you can see that the draft tape has been kept all the way to the top. So let's look at how to put a mounting boss onto the lower casing and in the top casing. So I want to start off with the lower casing, and for that I want to hide my upper casing, and then select mounting boss, and then you'll see that it gives you in sequence what it wants. So select a face. I'm going to select this face a little bit close to the edge, just to see what happens. You see nothing appears. Now that's because I've actually selected a point close to the edge, and these dimensions won't allow it to be placed there. Won't tell you anything until you've gone through this whole sequence, and then it'll give you an error message. So a good idea, I'm going to deselect that, is to select in the middle of your item, and your boss should appear straight away. If it doesn't appear straight away, you know you've selected in the wrong place. Just deselect the face and select in the middle again. The face that I wanted to orient to is the top plane, or the plane actually. I can change direction, so I'll place it on the underside. So if you get it facing the wrong way, just click on this button. And then we don't have a circle in place to help place this item, because I want to show you the other way to do it. And we're going to use hardware boss, and we're going to use the thread version, the head version, not the thread version. That's because this is the place where we're going to put the screw into. And here we're going to enter the boss height. We're not going to use select mating face. That will apply on the upper casing. Right, so I kind of have an idea of what this thing should look like in terms of size. It's gone in angry red because there's a contradiction with the fins at the bottom. So let's just hide the fins for now by typing in a 0. So we've got no fins. B, I want that to be about 7. C is the width of this little top hat. And I'm going to make that about 5 point, maybe a bit less. I think it needs to be 4.5, but I want to make it a little bit bigger than I need to, because I want to show you if it's too big what happens, how we can change that. Then D is just the height of that little top hat. I need it to be pretty small, 0.5, just to locate the PCB on. E is the degree of taper. I want half a degree. F is the width of the hole, so I'm going to be putting an M2.5, not an M3 as I said in the lesson, because it won't fit. M2.5 is fine. So the hole there needs to be a little bit larger than 2.5, and 3.2 looks good to me. G is the width at the bottom, so I actually need to know the height of my M2.5. I mean the width or the diameter of my M2.5 head, which I don't at the moment, but for now I want that there to be this dimension B, minus 1.6. So I'm going to choose a wall thickness of 0.8. So 1.8 times 2 is 1.6. So I can do the calculation in here. So I can say 7 minus 1.6 and hit enter, and it'll give me the figure 5.4. And then H is the wall thickness at the top, which should be 0.9, the same as my wall thickness for the entire part. And then lastly, half a degree bottom. I'm going to unselect this, should place it. Okay, and it has placed it, right. So now we need to make the position of this boss sort of movable. So the first thing I want to do is I want to click on that point. That's a 3D sketch point. And I want to click on this face, and then you should get this dialog box on the left in which you can select on plane. So I've already done it, but if you select on plane, it'll just constrain that point to this plane. I also want to constrain that point to the right plane. So let's just click select. So they're both selected, and then I can say on plane. I actually don't need to do that, but just to show you that you can do that. And now I want this point to be positioned relative either to this origin point or to some other feature. So the easiest way to do this, which I didn't show you on Thursday, is to go perpendicular to that point and then put in a center line, a construction line, straight down, and make sure that that point and the end of this line are coincident, right? So that's sometimes doesn't want to select it. Okay, and you'll see that you don't have the conventional relations. You have only one of these is available to you along Y. I'm going to, because that's black sort of bolded, I'm going to select that. All right, so now that point is linked to this line, and if I put a dimension in, and I change the dimension, it'll change the position of that point and consequently the position of the boss. Right, so that's that part done. So now I want to go to the top half. I'm going to make both of these visible. And the easiest way to do this now is to put in a section view in this orientation, sort of transversely. So now I can see both sides. I can see exactly what's happening. So I'm going to go back to mounting boss. I'm going to select, wait, before we do that, I had suggested that we use the pin boss and we use the hole as a substitute thread, but it's not really the best way to do things. We should go back to hardware boss. Hardware boss deals with everything that connects these things. So the thread, the head, and the thread. So we're going to choose thread, and then I'm going to select the face. And once again, I'm going to make sure that I select somewhere in the middle. There you go. So it should give you a boss straight away. If it hasn't, then you know you're not on target. Top plane again. Okay, just reverse that direction. Oops. I obviously said okay to that too quickly. I want to reverse that direction. And now, instead of entering boss height and selecting all of these things, I'm going to select this mating face, which would allow me, if I can see it, allow me to select the face underneath. So let's just right click and say select other, and it'll give you, should give you none of those. Might have to go here, just go like this, and there we go. So I can select, so it's that face there is the one I want to mate it to. Let's go back into this one here, and the offset I want, right, so that's the face. Have a look at the bottom here. Here's the offset that I want. So I want it to be about 0.6 of a millimeter. That's because I want to trap my PCB between these two, and I can always adjust this later. But you can see straight away that the fins are giving us problems again. Let's put a 0 in here, just to get rid of them for now, and then go through this. So B is the width. That only needs to be about 6, I think. Put it in, see what happens. And once again, half a degree taper. D is the is the opening of this recess, so which is the reciprocal of this sort of pin on this side, or this top hat piece here. So at the moment, it looks about right. Where was it? D 5. Okay, and then E is the hole size, which I need to be about 2.2. And then F is the depth of that little recess, which I need to be quite small, so I'm going to make it 0.25. I actually don't want it at all, but you can't enter a zero figure, it won't allow you. And then G is the height or the depth of the hole. I'm going to make that 6 and see what happens. Yeah, that looks like it might work. And then once again, these two tapers, I'm going to make 0.5 and 0.5. Right, and then I'll deal with the rest in another clip. So how to enter all of these pieces. Right, so I'm getting an error message here. It's red because one of the figures is contradicting. 600. That's why. 6 millimeters. Say OK, and it's done it. And if I just alter that, there we go. Okay. Right, and so I'll explain the rest in another clip. So I thought I'd show you briefly some of the aspects of how to make the fins that might help you. So the thing to watch out for here is the C. It's 4. I've got it at 4.5. Just make sure that that is less than A here. So that's the starting point, I think. Make sure that I've got mine at 4.5. Here, the height of the boss is 5. So that would be where I'd start off. And then the rest is just filling in detail. So this is the fin length that's measured from the center of this boss to the edge of the fin, or to the point at which it starts tapering down. B is the width. So actually, let's just fill these in. 4 in here just to show you, right? So that's A there. That's from about that point there to the center. B is the width, so that's the width at the base of the fin. 4.5 is the height, so that's that line there. D is just the degree of taper, that's 0.5 in this case. E is just how far from this edge to that edge you want the chamfer to start, and then F is just the degree of chamfer. And then obviously you can enter in here as many fins as you want, and then you can orient them as well. In this case, I've used front plane to orient them. Let's quickly see if we can show you what happens with right plane. So you won't see a difference with this, but if you put the 3 in, then you will. So that's obviously, that wouldn't be ideal from a molding point of view. Front plane would be better, I think, yes, because now you've got this lining up with the center. Okay, so that's how you would do the fins. It's not that difficult, just to remember to start off with make sure that C is less than A. Right, and so before I exit this, I just need to make sure that I've selected a vector. So it's going to be one of the planes, or be the right plane. Let's see. Yeah, I want front plane instead. So that will align this fin up with this fin in the right direction. So this should all be okay. I need to make sure direction would be top plane. All seems to be okay. Let's see what happens. Didn't like that. Why? No, it did. Great. It's in place. So all I need to do now is to make sure that this sketch is paired to that sketch, so that I can drive both using just one dimension. Let's go to normal 2, right? So that's not what we want. We'll make sure that that and the right plane, so I'm going to hold the shift button down, are paired. So that's on plane. And then lastly, I want that and this one here to be lined up. So I should be able to click. I've shift clicked both of those, so I've got them both selected. along Y is available to me, and I've got it. And let's see if we just renew this a little bit. There we go. And so it's in place. Everything is neatly lined up. Let's select another view just to make sure that it's correct in this orientation as well. And it is. Okay, and the reason that it's nicely lined up is because I've made sure that that point there and the point on this 3D sketch are coincident along the y direction. I've remembered now how to save one of these bodies as a separate part. This was something that I'd forgotten in the lesson. If you select one of these and you right click, you just say insert into new part, and it'll ask you what template you want to use, which is that part template. Make sure it's the part that you, or the half that you want. So I want just, it doesn't matter, maybe we can select both. Let's try both. No, we only want one. And then just select the where you want to go and put it. So I'm going to go to UJ, exercise files, Solidworks, and key fob. So I'm going to need to make it something. Actually, I think I should be able to overwrite this file. Let's see. No, I'm not going to overwrite it. I'm going to call this E just in case. Let's say yes. And change the units. And so it shows you straight away what you've saved. And there you have it. Close that off. Select this one here, right click, insert into new part. It is the lower casing that I want, not the upper casing in this case. Right click that, put an E on the end so it matches the other one. Oh, it's the upper casing. No, so it's the lower casing I want. Just type that in. E. Say yes. And change the units. And there we go. It brings it straight in. Right. Now, I had shown you how to make an assembly file from those other parts. So we're going into conventional assemblies now. So I'm going to open one of those ones. Let's say it's the lower casing, E. And it's in place already. Remember just to have a look quickly at whether this is, it's already, it's only a part. So if I save it as, no, not drawing, file, make assembly from part, and I select that template. It's going to ask where I want to bring it in. Remember, if I just click the OK button, it'll bring it in the same orientation in which I made it. You can right click here and just check if the float button is available. That means it's fixed. You can also check that the front plane and hold the control button down, front plane of the assembly match one another, which they do. And the same would be for the other planes as well. I'm not going to go through all of them. There we go, those two match one another. So it's exactly where I want it to be, and so I can save this assembly. So Control S, save all. I've got key fob assembly. I'm going to reuse that file name and just going to call it E so that everything ties together. So now I've got an assembly file with a single part in it, and I want to bring the other part in. So I'm going to insert part, browse, uppercasing E, I think. And once again, because this has been created in place, I don't need to go and place it here. I just click the OK button, and it'll do that. Everything's lined up. So that's the quickest way. You don't want to go mess with this. This is already all established. You don't need to re-establish anything. I'm going to hide this for now. And I want to bring in that PCB. This is where we went a little bit wrong in the last in the lesson, and that I think really had to do with me not saving the file and running OBS Studio at the same time, which meant that I had no RAM left, and so I think SolidWorks was referencing old commands because there was no space in the RAM to sort of swap commands around. So one of the ways you can speed SolidWorks up is to keep saving your items just to clear the RAM. Insert components, PCB. Remember, I dropped this in, so I could go like this, okay, but it's not quite where I want it to be. But you'll notice straight away that I can't do anything with this. I can't move it around. So I need to go and unlock this, so I make it float, and now I can make it float. So the thing I was trying to show you in the lesson was how to use one of the advanced mates. So if you hold your shift button down, you click on a face, let go of the shift button, you don't have to hold it down. Hold it down again, click, keep it held down, click. So select the 4 faces you want, and it should then give you a dialog box. If it doesn't, just go to mate. And it'll immediately go to the only mate available to you given those 4 faces, which is the width mate, which is under advanced mates, which is a very, very nice command to use. So that now this piece is from, if I go to the top view, I can't move this left to right, but I can move it up and down. And if I go to, it's not what I want. If I go to another view, let's go to, no, not that one, this one here. I can move this up and down, but I still can't move it left to right. So it's fixed left to right, which is ideal. And now I want that and this, hold the shift button down to be concentric. And I want this to be facing the other way around. So I need to go to mate, go to width, and I can flip mate alignment, which will just swap the mate alignment. There we go, it'll swap it around for you. Done. And then I want that face and that face to be coincident. And coincident they are. And I can see that this piece here is now too big for that hole. So I need to go and make it smaller. Is to measure this hole, which is 4.3, and then go into my multi-body part and change just that piece there. So I can just go to feature, and it is C, which I want to be less than 4.3. So let's make it 4.1. Should update. Done. And if I go back into the assembly, now I can see that there's a gap between the two. So that's that done. And now I need to put in the battery. Let's drop the battery in just to show you again how that SmartMate works. So browse and select my battery, which is this one here. I'm just going to drop it in and then select face, shift, select face, shift, select face, select. Put that in place, say yes, I'm happy with that. And then I'm going to put that face tangent to that one. And then I want that face to be offset from this face. So hold the control button down. Give us a mate. So it's given us coincidence, but I want distance. I'm going to make the distance about 0.35. Click OK, finish mates. And you can see that the battery is now going to interfere with this body, and I know I've got space in the front here for this thing to move forward. So I'm going to quickly go and do that. Not sure by how much, but I've got lots of space. So let's quickly go into this one. Go straight into the sketch. Make that 16. Is that correct? It's going the wrong way. So no, this must be about 4 or so. Let's see what that does. Assembly. So there we go. It's moved a whole lot forward. Now a bit too much. You can see now the PCB is in fact interfering with this piece. So 4 was not the right dimension. You can change that, but you can see if I went back to say 6 or 7, I could get the whole lot to move back, and everything's done. And that's as much as we need to deal with for now.